We want to simplify the given complex fraction, and we'll show how to simplify the complex fraction using two different methods. Method 1, we begin by simplifying the numerator and denominator if possible. So looking at the fraction on top, let's write it as x over x squared minus 4 is the difference of squares. So we'll have two binomial factors. We'll have a factor of x plus 2 and a factor of x minus 2. Remember, to try to simplify a fraction, we do want to factor any expressions. Now on the bottom, we have 5 over the quantity x minus 2. So notice how in this case, the fraction on top and the fraction on bottom don't simplify. So we move to step 2. Step 2, we write the complex fraction as a division problem. Remember, a fraction bar means division. So because this fraction bar means division, we can write this as the fraction on top divided by the fraction on the bottom. From here, we'll write the quotient as a product. Dividing by a fraction is the same as multiplying by the reciprocal. So we can write this as the first fraction stays the same, and instead of dividing by this fraction, we multiply by the reciprocal. So we'll have a factor of x minus 2 on top and a factor of 5 on the bottom. Now before multiplying, we want to simplify. Notice how there's a common factor of x minus 2 between the numerator and denominator. X minus 2 over x minus 2 simplifies to 1. Now we multiply. On the top we just have x times 1, which is x. On the bottom of the denominator we have the quantity x plus 2 times 5, or 5 times the quantity x plus 2. So this is the simplified form of the complex fraction. If we wanted to, though, we could distribute the 5 in the denominator and write this as x over 5x plus 10. Either form is acceptable. Let's leave the denominator in factored form and enter x over 5 times the quantity x plus 2. To enter this correctly, though, we should use the equation tool called MathQuill, or from the keyboard, we would need parentheses around the entire denominator. So using the keyboard, we'd have to enter x divided by, open parenthesis, 5 times the quantity x plus 2, then another closed parenthesis. Now let's simplify this again using the second method. So beginning with the original complex fraction with this denominator in factored form, step 1 is to find the least common denominator of the fractions in the numerator and denominator. So notice how on top we have a denominator of the quantity x plus 2 times the quantity x minus 2. On the bottom we have denominator of the quantity x minus 2. So the least common denominator would have to contain a factor of x plus 2 and a factor of x minus 2. So now we know the LCD is the quantity x plus 2 times the quantity x minus 2. We move to step 2, where we multiply the numerator and denominator of the complex fraction by the LCD. So we're going to take this entire complex fraction and multiply the top by the quantity x plus 2 times the quantity x minus 2, and we'll multiply the bottom by the same. Remember, when we multiply the numerator and denominator of a fraction by the same value or the same expression, we get an equivalent fraction. Now looking at just the top, if it's helpful, we can think of these two factors as a fraction with the denominator of 1. So when we multiply, notice how we can simplify before multiplying. X plus 2 over x plus 2 simplifies to 1, and so does x minus 2 over x minus 2. So now multiplying on the top, we just have x times 1, which is x. Now looking at the bottom, again, we can think of these two factors as a fraction with the denominator of 1. Notice how we have a common factor of x minus 2 between the numerator and denominator, which would simplify to 1. So now multiplying on the bottom, we have 5 times the quantity x plus 2, which we already know from method 1 is a simplified form of the complex fraction. Or if we wanted to multiply the denominator, we'd have x over 5x plus 10. I hope you found this helpful.